Hello everyone, my name is Chuan Ruo, currently a senior researcher at Microsoft Research. Today, it is my great pleasure to present our work at EXE 2021. The title of our presentation is AutoCCAG, an automated approach to constraint covering array generation. Let's start. Nowadays, there are increasing demands for customized software and service. A highly configurable software system provides many configuration options, through which users can easily customize the system. For highly configurable systems, faults are introduced by the combination of several options. However, testing such systems is challenging, since there are a huge number of possible configurations for a highly configurable system. For example, if a system has 15 configuration options, each with 3 possible values, then there are more than 10 million possible configurations in the worst case. Here, we give a toy example to show a configurable system. For this case, there are 3 options, including operating system, browser, and payment method. Each option has 4 possible values. For this case, there are 64 possible configurations in total. Here, we note that for real-world application systems, some configurations are invalid. That is to say, there are constraints among several options. Also, extensive studies show that faults are usually caused by the interaction of 2 to 5 configuration options. As introduced before, it is impractical to test all possible configurations, which urgently calls for effective testing methods. In this slide, we introduce the concept of covering array, CA. A T-way CA is a set of configurations, and ensures that any combinations of values of T different options is covered at least one time. Actually, for a configurable system, a CA of a smaller size is better, since testing such smaller CA would result in less testing cost. As a result, for a configurable system, how to generate a smaller CA is critical. In this slide, we give the formal problem formulation. In our work, we focus on solving the problem of constraint covering array generation, CCAG. The CCAG problem aims to generate a CA as small size as possible. In practice, for a configurable system, there are many hard constraints on the option values. So the CCAG problem also considers those constraints. In theory, solving T-way CCAG is challenging, since T-way CCAG with no smaller than 2 has proven to be NP hard. Actually, existing CCAG algorithms mainly focus on solving 2-way and 3-way CCAG. In fact, existing CCAG algorithms can handle 2-way and 3-way CCAG well, but effectively solving 4-way and 5-way CCAG still remains a big challenge. Compared to 2-way and 3-way CCAG, 4-way and 5-way CCAG have many advantages. First, large-way CCAG has higher fault detection ability. Second, large-way CCAG can find corner case faults that could cause serious consequences. Third, large-way CCAG might bring benefits for life-critical applications. Hence, the main idea of this work is to leverage automated algorithm optimization techniques to solve CCAG. Automated algorithm optimization techniques include automated algorithm configuration (AAC) and automated algorithm selection (AAS). AAC aims to determine the optimized configuration for a configurable algorithm, while AAS is to select the most suitable algorithm from a set of candidate algorithms. Both AAC and AAS have shown effectiveness in various application fields and in solving diverse NP-hard optimization problems. Based on automated algorithm optimization, we present AutoCCAG, an automated approach to CCAG. AutoCCAG has three important components: configuration optimizer, permission configuration generator, and configuration scheduling planner. Configuration optimizer determines an effective configuration for target CCAG algorithm based on automated configuration. Permission configuration generator recommends a set of permission configurations with complementary strengths. Configuration scheduling planner allocates suitable time budget for each permission configuration. For configuration optimizer, the core problem is how to determine an effective configuration for a target CCAG algorithm. AutoCCAG uses Bayesian optimization framework and strikes a balance between exploitation and exploration to obtain good practical performance. For permission configuration generator, the core problem is how to recommend a set of permission configurations with complementary strengths. To address this problem, AutoCCAG works in an iterative manner. In each iteration, AutoCCAG calls its configuration optimizer to focus on such training instances where those configurations selected in previous iterations do not work well. For configuration scheduling planner, the core problem is how to allocate suitable time budget for each permission configuration. To address this problem, AutoCCAG calculates each candidate configuration's marginal contribution. Then, for each permission configuration, AutoCCAG allocates the time budget that is proportional to its marginal contribution. In order to present the effectiveness of AutoCCAG, we conduct extensive experiments to compare AutoCCAG with state-of-the-art competitors. In our experimental setup, we adopt two testing benchmarks, real-world and IBM. The real-world benchmark contains 5 application instances encoded from real-world application systems. The IBM benchmark includes 20 practical instances, which cover diverse application fields. Also, we adopt a synthetic benchmark as the training set, which is used to train AutoCCAG. We adopt 3 state-of-the-art competitors, including TCA, CASA, and CHIP. All of these show good results in solving CCAG problem. In this slide, we present the experimental results on 4-way CCAG. As you can see in this table, AutoCCAG achieves the best performance for solving 4-way CCAG on all testing instances. Also, we present the experimental results on 5-way CCAG. It is clear that AutoCCAG achieves the best performance for 5-way CCAG on all testing instances, except Apache and GCC. For those 2 instances, the running time required by all algorithms exceeds the cutoff time. Here, we summarize our work. Solving 4-way and 5-way CCAG is important, since they bring much benefit in practice. Also, solving them still remains a big challenge. We present AutoCCAG, an automated approach to CCAG. AutoCCAG leverages the effectiveness of automated algorithm optimization techniques. Also, through our extensive experiments, AutoCCAG achieves the state-of-the-art performance for 4-way and 5-way CCAG. Thanks very much for your attention. That's all.
Hello again. So we are now in the live part of Juan Luo paper. I hope you enjoyed his presentation, and the author is ready to take your question. Do you want to ask something to Juan Luo about his AutoCCAG tool? Okay, we wait for question in the chat, Juan Luo. And meanwhile, I have some question, of course. So first thing I want to ask is a general question, no? Because you have this very nice algorithm to address four-way and five-way interaction faults. I am not very expert about this, but I think to remember that in reality, these kind of faults are not very common. Do you have any statistics about how frequently or what is the impact of four-way or five-way interaction faults?
Yes. Actually, in the introduction part, we have discussed this. As what you said, the most common faults are the two-way and the three-way ones. But for some corner case, the four-way and the five-way is also very important. For example, for a recent study at LG Electronics, the researchers from that company use four-way and five-way CCAG to detect very serious issues or faults at the washing machines and the refrigerators. And they said that if these faults are detected after the sale, they will maybe lose millions of US dollars. So that study confirms that the importance of four-way and five-way CCAG.
Okay, and this area of research of configuration constraint covering array testing is actually quite old, no? I remember there are works already from the 19th about this topic. So do you think this is still an area that continue always to improve, or at a certain point we have solved the problem?
From my understanding, if you treat it as a mathematical problem, it is not solved. But in practice, because as I remember a study says that all the practical faults can be detected between one-way CCAG and the six-way CCAG. So now we have adjust the five-way one. So maybe if we can also do a bit more to overcome the six-way, and I think this problem maybe can be saved, is solved. But I think even though we solve the six-way, but we need to reduce the size of test suite. So maybe this is also very interesting to do that. But in practice, we are doing very well now.
Okay, very good answer, actually. Thank you, Juan.
Yeah, thanks.
I don't want to take all the floor for the question, but I don't see from the audience in the moment in the chat. So in general, I saw that you are not an academic researcher, you are from Microsoft. So I am curious to know if this kind of approach that you studied is applied in Microsoft, and for testing, if yes, for testing what applications?
Yeah, we have applied it in Azure. Microsoft Azure are a cloud system of Microsoft, and because for that application, we need to because if we have a system of software, and we need to ensure that all the hardware combinations can be compatible with that software. So what we do is that we create or set up a lot of
machines with different OS image, hardware skill, and something like that to test the software. So that way, we need the test case is actually a testing machine. So if we can reduce the test case, so we can reduce the number of testing machines. So we applied our algorithm in that scenario, and our algorithm has reduced around maybe 20% testing machines. So I think this is also an application, but this is done after we publish this paper. So that application is not described in this paper. So I think it is actually very useful.
I see. In fact, I saw in the presentation you speak about testing on benchmark, and I was curious to understand why it was not also tested in real case, but you did afterwards. Very interesting.
Yeah. Thanks.
Okay. We have still 3 minutes to go. Another question? There is something you want to add also that in the tight minutes of the presentation you could not describe? Maybe some future work you are working right now?
Actually, maybe I can post an advertisement of my new FSE paper here. For my FSE paper, I developed another algorithm to solve a related problem. For this problem is that we for the AutoCCAG problem, we want to create a test suite. But this test suite should guarantee the 100% coverage, and we want to minimize the coverage. But for some very huge systems, the test suite with full coverage is very large. So for my FSE paper, we developed another algorithm that we given a fixed number of test cases. So could we maximize the coverage? And I found that this tool is very useful because we can use maybe 1/10 test case to achieve more than 95% coverage. So that paper, I think, is also very useful, and we solve the problems in a different way. Yeah. So maybe others can read my FSE paper, and I will also continue to do this program in the future work.
Nice. So you very recently got the notification of the paper acceptance, right? It is FSE this year?
Yeah, FSE this year.
Okay.
Yeah, a few days ago.
Yeah, very novelty, a new announcement that you did. Okay, so Juan, no more questions, and congratulations for this work and for your next coming work as well in the FSE. We are all the same community, more or less, so we will probably see each other also there in FSE.
Yeah, thanks.
Okay, and you can, we have 1 minute left, and after it ends, you can enter the discussion room. And if someone want to make you question by voice using microphone and the camera, this is possible in the discussion room as well.
Okay.
Okay, congratulations. Thanks for the nice talk and for answering all my questions.
Yeah,
thank you.
Thanks very much for your question and hosting this session. Thanks.
Thank you. So I close. Bye.